projects. I wanted to just get an idea of the audience. How many people are UDOT employees that are in here? Okay, a few consultants. See a few of those. Is there any others? I guess vendors, local government. Okay, great. Welcome, Arthur. This course is about documenting historic structures using 3D laser scanning, and it's pretty neat. And I might just mention too that this presentation, this is done in a story map application. Yesterday, Carlos introduced it briefly in his conversation, but it's a pretty neat application. Basically, everything is web-based. Everything is one web file. I've kind of described it as a combination of PowerPoint together with GIS. So you'll notice the left side of the slide will be static as we go, but the right side of the slide will be dynamic, and we will zoom in and out of a number of maps. The good news for everybody is you won't have to listen to me for the next hour and a half. I will speak a little bit, but we have some other people here too that I want to introduce. We have kind of a panel. Nancy Calkins, you want to stand up for a sec, Nancy? Nancy is an architectural historian. She's been working with Horrocks Engineers for a little over 10 years now, I believe. 14. How time flies when you're having fun. And we appreciate her being here. She was very involved in this project that we're going to talk about today. Daryl Devey is from the Central Utah Water Conservancy District, and he was our client on this project. We are going to talk about a specific project today and use it as a case study for what we did. And it was a Central Utah Water Conservancy District project, so we appreciate Daryl taking time and being willing to participate with us today. Nicole Tolley is, I guess, the brains behind everything we're doing today, and she will talk quite a bit to us. A couple of housekeeping things. There is a sign-up sheet that I'll pass around, and we do have some paperwork for continuing education credits. I believe if you're out of state and need those credits, you need to get a paper. I believe if you're in state, you can just sign up on the sign-up sheet that we'll pass around. We want to operate this kind of like a discussion group or work group. We will have time at the end to take questions, but if anybody has anything that prompts you during the discussion, please raise your hand and let's talk about it as we go. We want this to be a very open exchange. Trying to think if there's anything else here in the preamble. We do have some learning objectives listed. That is part of the continuing education requirement. So we didn't put too many of them down there, but we do have 4 learning objectives. The first one is the project history. As we get into this, we will talk about a specific project, and it's pretty neat stuff. Second, we're going to do a brief overview of Section 106. I see a few people in here that are familiar with Section 4F with federal highways and Section 106 with the state that deals with cultural resources, historic properties. We're going to talk about some of these innovations, and I think that's probably the main reason people are here today, is to learn about some of these things we've been able to do to document historic resources using laser scanning. It has really raised the bar on what can be done and what can be given to the State Historic Preservation Society. The last thing we want to do today is we'll talk a little bit about how this can apply to transportation. This is a UDOT conference. Most all of us are transportation professionals, so at the end we'll tie it all together for you and how you can use it in transportation. Let's move on to the next picture. Here on the left, if anybody can see that, does anybody know what that is or where that is? No, Ryan, you can't answer. Anybody else? Go ahead. Here in the back. Mouth of Provo Canyon, and what is it? Yep. Yep, the penstocks. This is the pressure box for the Olmsted Hydroelectric Power Plant at the mouth of Provo Canyon. And this is the project that we're going to use as our case study today, that we're going to talk about things that have gone on there and what the current status of this hydroelectric plant is. There on the right, you can kind of see it zoomed in a little bit. You can see Provo Canyon Road, and as it ties into 800 North there in Orem. And the area we're talking about is right on the north side of the Provo Canyon Road. Let's go to the next slide, please. This was such an interesting and important project that we wanted to take a few minutes this morning and talk about the history of the Olmsted Hydroelectric Plant. We wanted everybody to understand the importance of this facility, and then it'll make more sense why we have done what we have. And we want Nancy, if she would, to take a few minutes and tell us about the history of the Olmsted Hydroelectric Power Plant. And you've got microphones there, or you're welcome to this one.
It's a great way to answer. All right, the pressure box that you saw earlier where basically the giant valves are that allow the water to go down the penstocks. And this is an image, a current image from that pressure box. And then that right there is an image 112 years ago from the same location. Slide it back and forth for a second. It's pretty cool to see how much of it is still there, although you can see UDOT's influence there in the background. And notice how much of the mountain UDOT has removed. Okay, the other thing I want you to notice before we leave the historic slide is that on the right you can see a road coming around the hillside. That's the Provo Canyon Road where it used to be, and it ran right through Olmsted. In order to understand why this hydroelectric plant is at the mouth of Provo Canyon, we kind of need a little bit of a backstory. And to introduce that, does anybody know where the first alternating current transmission, long distance alternating current transmission was in the entire United States? It went to Mercer, which is out in the middle of nowhere. It's a mining town. Do you want to show the town? This is Mercer in its heyday. It doesn't exactly look like that anymore. But the power went to the mines in Mercer, and it was transmitted 32 miles from Nunn Station in the middle of Provo Canyon. Does anybody know where Nunn's power station was? Anybody been to Nunn's Park in Provo Canyon?
Yeah, it's a park now, right?
Yep, that's where the power station used to be. It was called, yeah, there's a picture of the power station in Provo Canyon when it was working. It's called Nunn's Power Station because it was built by the Nunn brothers, Paul and Lucian Nunn, who were farm boys from Ohio. Lucian is the one on the left, who was a very savvy entrepreneur and went to Telluride, Colorado to seek his fortune. His brother Paul on the right was a high school science teacher in Massachusetts. Lucian became the manager of a gold mine in Telluride and decided that it would be less expensive to run the gold mine with electricity than to run it with coal. And so out of that little shack right there, he and his brother pulled off a grand experiment of using alternating current, which Thomas Edison had said was too dangerous and should never be done. Lucian Nunn had an uncanny ability to pull together finances and the right people to do what he wanted to accomplish, and he convinced Nikola Tesla and George Westinghouse to come and show them how to do this. And so that little shack was the first transmission of alternating current in Telluride, Colorado, first anywhere. After their success there, they formed Telluride Power Company and started to expand into the west and came to Utah because of there was lots of water in the canyons and there were lots of mines. He saw this new alternating current transmission as helpful to industry, although it changed all of our lives, and we use alternating current in our homes. Clear until the 1930s, most people only had a light bulb hanging from the middle of their ceiling, and that was the extent of electricity in homes. So what he did, they made this transmission to Merkur. They immediately added on to, do you want to say how far they went with that?
The transmission line was 32 miles.
And then they added on to...
Oh yeah, again, this was power in its infancy, and they immediately recognized the importance of this, so they took the power line down to Eureka, and then they took it up to Logan, and they kind of created this great big gigantic triangle grid off of these couple of little hydro plants that were built in the mouth of the canyons where there was water.
Thanks. So what they needed to do, because they're expanding this so quickly, there was not enough pressure in the fall of the water at Nunn Station, and they could not generate enough power. So they moved to the mouth of the canyon, and they brought the water, so they had to extend the flume another 3.5 miles down the canyon. They had to blast a tunnel through the mountain. And by the way, I've been up here, and I don't know how this lady got up here in a long skirt, or it scared me standing in a building up there, and she's on a piece of wood. But anyway, they had to build a flume through that tunnel. This is on the uphill side of the tunnel, and you can see the guy down there. That thing was huge. And then, is there another picture of the flume through the tunnel? No? Then they had, I can't read. Oh, they had to build the penstocks to carry the water from the tunnel down the hill, and then build a much larger powerhouse at the base of the hill. This was not a small undertaking. You can see this image from the opening of the tunnel. At this time, they have 6 buildings under construction and 3 that have already been completed. The first building they completed was a boarding house where everyone ate. But most of the people did not live in the boarding house. They lived in tents. You can see the tents in the background there. You can also notice on the train right there, there are crates from General Electric where the generators came from. I do want to tell you a funny story about the tents. When they were blasting through the tunnel, they would set the blasting caps or whatever it was. Anyway, they would set it off before they went to lunch, and while they were at the lunch, it would settle down and then they'd go back. Well, they went up one day and they had blasted into a rattlesnake den. But it was wintertime and they were all dormant. One of the employees, unbeknownst to everyone else, picked up a gunny sack and put 25 rattlesnakes in it. Kind of casually went back down and put inside everyone's cot in their tent a rattlesnake at the bottom of their bed. And when they got in at night and stoked up their fires and heated up their beds, the rattlesnakes kind of came out of dormancy. And there were yells that were coming up all over camp, and they all realized there was only one bed that didn't have a person or a snake in it, and it belonged to Frank Dusenberry, who had gone home to Provo that night. And when he came back the next morning, 4 guys picked him up and threw him in the river. There was lots of stuff like that that went on. Apologize for my allergies. Okay. The next buildings they built were utility buildings. There was a brick stable, a carpenter shop, a blacksmith and foundry, a garage. They had automobiles very early on. They built roads through the campus. I thought UDOT people would enjoy this steamroller. They would take the rocks that they had blasted out of the tunnel and bring them down, spread them on the roads, and then smash them with this. They also built, this is the county road that's going between the powerhouse and the brick stable. And in the fall, they would sometimes have 100,000 sheep pass behind the powerhouse in a day. They built a train depot, which is up there on the left, and then the railroad spur that went from the Rio Grande tracks that went right into the powerhouse, as you can see. That's how they got the heavy equipment into the powerhouse, and then there's a crane that lifted it off and placed it. In addition to this being a power station, it was also built as a college campus. Lucian Nunn had very strong feelings about education, and this was a very new field, so he not only educated his employees to run, do you want to show the next slide? To run the powerhouse, he also gave them the first 2 years of their education for free, and then would send them to universities with a scholarship to finish their education. Places like Cornell, University of Michigan, Berkeley, he had places there for them to stay. And as a result, his employees were extremely devoted to him. He built a dormitory with classrooms. This is during construction, because you can see there's no windows in there yet. The upper 2 floors were the dormitory, and the bottom floor had classrooms and a library. He built a laboratory where they performed experiments on electrical equipment, which often ended up in flames because they would push it to the limit so they'd know when it was going to blow up. He built residence for Paul Nunn, who was the chief engineer. Lucian Nunn lived in downtown Provo, and actually we have University Avenue because Lucian Nunn lived in downtown Provo and wanted a decent road out to Olmsted, and so he convinced the city to pay for the first third, the county to pay for the second third, and he paid for the last third out to the mouth of the canyon. Built a home for the superintendent of the power plant and one for the dean of the Telluride Institute, which is what his college was called. It was a beautiful campus. It still is. It's still laid out identical to that. Many of those trees are very large and still there. To kind of, the landscaping, he paid a great deal of attention to landscape. At one point in time, they had a greenhouse there. This is the tail race that flows through the campus. It's where the water returns from the powerhouse to the river. And to complete the campus field, they had a ball field and a tennis court. The very last building that they completed before the power station came online in June of 1904 was the pressure box up at the top of the hill, which is the building you saw at the beginning. This is the first pressure box, and it was replaced in 1917 by Utah Power and Light. And this is the difference between the original powerhouse and what's there now. It's actually quite a beautiful place. I'm going to hand the mic to Daryl Devi, who's going to talk about the project and what's happening at this beautiful campus.
Thanks, Nancy. You can see that there's a rich history that's happened at the mouth of Provo Canyon, and it's something that all of us need to know about. You're probably wondering how the Central Utah Water District got involved with this old power plant. In August 18th of 1987, the United States Bureau of Reclamation condemned the power plant, the flow line that fed the power plant, and the water rights to be a portion of the Bonneville unit of the Central Utah project. One of the biggest reasons for that is we were building Jordanelle Reservoir, and there was a real need for a water supply for that reservoir. Now, just so you know, I teach a little bit about water rights, and hopefully I don't bore you highway guys too much about that, but of course you realize that with no water, there would be no people, and then there would be no roads, and you guys probably wouldn't have a job. So the water is really an important thing. So in Utah water law, there's a couple of things that are really important, and that is first in time, first in right, and then there's also the doctrine that if you don't, the water belongs to the people of the state of Utah. It doesn't belong to an individual, and so if you don't use your water, you lose it. And so that's the reason for this project. We had to have a water right to be able to put in Jordanelle Reservoir, and the power company was first in time, first in right, and there was no way that we could get that water to store in Jordanelle because they had the right to generate that water first. So we acquired that from them and offered them a settlement deal that any water that we didn't store, they could continue to generate and run the power plant, which is what they have done the past 25 years. Well, you can also see that this is our whole Bonneville unit of the Central Utah project, and if you look carefully, you can see Upper Stillwater Reservoir, the collection system, and all of that brings water from the Colorado River basin into Strawberry Reservoir. Then it goes through a series of tunnels and pipelines where it can be delivered to customers or put into Utah Lake. Now, believe it or not, the water right in Utah Lake has a much earlier priority than even the power right. And so we had a non-consumptive right that we had to deal with and a consumptive right. So we built the rest of the Central Utah project to deliver water from clear up at Upper Stillwater that goes into Utah Lake. And then we can exchange that water up to Jordanelle Reservoir by bypassing the power plant. I also mentioned that it's really important for us to be able to protect those water rights. If the power plant, as it's a non-consumptive right, if we don't have the ability to generate that power, we lose the water right and we lose our priority. It goes to the next appropriator in time. Well, the Bonneville unit of the Central Utah project, most of its water rights are in 1977. There's many water rights that intervene ahead of our water rights, so very important for us to be able to keep this facility. Well, we did an engineering study to see if there was a way that we could take that 111-year-old power plant and be able to rehabilitate it and be able to make it work so that we could continue to protect the water rights. And as we went in, we found huge problems with, this is the runner on the number 4 unit. And as we went through the history, we found that this runner's been replaced multiple times, but even right now, it's still in terrible condition. The windings are not in very good condition. This is a photo of the number 1 generator, which one day it was just operating, and you saw the picture of the fire that Nancy had. Well, we had that blowout of one of the generators as well. As the old windings, the insulation value is not very good, and so it arced over and flashed out. And so a couple of the other problems with the plant. What you see here is the bronze runner on the number 2 unit, and at the top and the bottom of the slide there, those plates of steel are called wicket gates, and those wicket gates are really a valve that controls the water flow into the turbine. Well, they let the wicket gates come out of adjustment, and those wicket gates rubbed on the runner, which wore the edge of the runner out. And we found out by running some data on this that these units that were probably about 85% efficient when they were put in were down below 50% efficient. And we realized that it was going to really cost us a lot of money to put this plant back into operation. Also, the pressure box, when you got up near the top, you can see that the concrete in that pressure box is really bad. There's some alkali aggregate reaction going on. There's a lot of places where they put the rebar too close to the surface and it's rusting, and as we get freeze thaw, it's pushing the concrete off the face of it. Well, this building is huge and it's tall and it's clear full of water, and we realize that we've got a risk there with the possibility of this giving way and creating a massive flood downstream, destroying the power plant as well as the campus. Lots of problems like that. And so our project is to take the old power plant and build a new power plant. And in the design of that, we looked all over to see if there was a way that we could move the plant on the United States property and be able to avoid some of the old buildings on the campus. But between power lines, not owning the property and everything else, some of those facilities were just in the way. And so Nancy talked about the rich history that's involved with a bunch of those facilities. So you can imagine how complicated this must have been to be able to do the historic preservation and document, what's going on with all of these buildings that have to come down. You can see the outline of where our maintenance building was planned and the power plant as well, which is right in the way of some of the blacksmith shop, the carpenter shop, the stable, and other things. And so the other thing that we had to do is to be able to get the water to this facility. We'd had a real problem in the past of regulating flow into this power plant because we have a 10 million gallon storage reservoir that's upstream of this. We would make a release to that storage reservoir and send it to the power plant, and then the power plant would increase its flow, and then it would decrease its flow, and so we had this big sine wave that's going on downstream in the Provo River, which I've got to tell you, we have an endangered species down there, and it wasn't really conducive to the health of the endangered species. So with the new project, we would be delivering water directly from that 10 million gallon reservoir, and the control gates would be the wicket gates that are on the turbines themselves. So just a little bit about the project and why we got involved with it. And one thing that I've seen over my lifetime, I've been with the Water District for 30 years, and in some projects, they say, well, that historic feature is just in the way, document it, tear it down, get rid of it, and we'll move on. This because, some of this stuff was the first stuff that happened in the United States. This is a very important facility to protect, and we found that, or we've had great support with our board and others to be able to realize that, hey, yes, we need to save and help protect what's going on with this site. So I'm going to turn the mic over to Nicole. I think Nicole's probably going to sit down and she's going to tell you a little bit about the 106 process and how we had to document this project.
Okay, thanks. I also wanted to point out that the powerhouse is actually going to remain in place, the original powerhouse, and the district is building the new powerhouse just adjacent to it. So I'm going to talk about the Section 106 process, but first I was wondering if anyone recognized this building here. Maybe from a TV show.
Is that one Granite Flats?
Yeah, it's Granite Flats. It's this building, which is it was the Telluride Institute, correct? What is the hospital in the TV show Granite Flats. A lot of that TV show is filmed on this campus. So if you enjoyed that show, you'll see a lot of those buildings. So the Section 106 process of the National Historic Preservation Act requires federal agencies to take into consideration the effects they're going to have on historic properties. And so the first step in the process is to identify historic properties. And a historic property is defined as a prehistoric or historic district, site, building, structure, or object included in or eligible for inclusion in the National Register of Historic Places. So Nancy did what's called a reconnaissance level survey of the campus, and she determined that there were 20 historic features that were that were either already on the register or eligible for inclusion on the register. The powerhouse itself is currently on the register. The next step is to assess adverse effects to those properties. And this is kind of an overlay of the historic buildings with the proposed action. So because the district is building the new powerhouse adjacent to the old structure, there would be a no adverse effect to the original powerhouse. That will remain in place. But there will be an adverse effect to the pressure box, which is going to be removed, to the penstocks, which will be replaced and buried. And then, as well as to several of the auxiliary buildings, to the brick stable, the blacksmith shop, and as well as to some of the historic landscaping, including the tunnel. Anyway, yeah, just because to make room for the new powerhouse and the maintenance building and construction access, these buildings had to be removed. And then one of the last steps in the Section 106 process is to resolve those adverse effects. As both Nancy and Daryl have explained, this resource is extremely important to the role of hydroelectric power, not just in Utah, but in the United States. And as a result, the district wanted to make sure that the mitigation was kind of above and beyond what we normally do. And so they signed what's called a memorandum of agreement with the State Historic Preservation Office that included a lot of stipulations that we usually see, such as data recovery, IMAX site forms, intensive level surveys. But this one's pretty unique. It's virtual renderings of historic structures. And so usually we record historic buildings through static mapping and photos. We used to hand draw maps. This is a map of the Olmsted campus. And now we've progressed to aerial imagery, so at least you can get a better context of what the property looks like. But to fulfill the virtual rendering stipulation in that MOA, the district proposed that we do 3D laser scanning of the historic features that we would be impacting. And Stan's going to talk a little bit about that.
Is this still working? No.
It should be on. Go ahead.
Is it working?
Yeah.
Okay, good. 3D laser scanning, that's a pretty fancy word. How many people out here have dealt with any type of this 3D scanning? Either at the city level, the state level? I think now at UDOT too, it's becoming very common to be part of all of our projects to do the laser scanning. Here in the picture we have, down in the bottom left, there's a little picture of the laser scanner. And just wanted to hit on a couple of details. The equipment we have takes about 6 minutes to do a scan. And with that, you get millions of points, on the order of 15 million points per scan. And if you want to upgrade your scan to a 12-minute, then you get photos together with it. And as we go through some more of this, we'll show you some of the laser scan point clouds that we created, and also some of the photo imagery that comes along with the scan. It makes it really practical to be able to do panoramic views of your projects. And this technology also applies very well to linear projects. This project was more of a campus type setting, but it also works really well for roadways. I mentioned the point clouds. Here in this picture you can see one of the point clouds. We've got a lot of the points turned off to make it easier to turn on and off and move in and out of for this presentation. but millions and millions of points, and you can mend these point clouds together. So every 6 to 12 minutes, you can take a series of 15 million points and lace them all together. So very data intensive application, but very worthwhile. And it's just like having individual survey points on all of those locations. So you can measure between them, you can use them to calculate quantities. Very, very useful application. And that's probably enough on that at this point. Let's move on to the next piece.
All right, so this next section, we want to talk about the advantages of 3D laser scanning for historic documentation. I'm just going to go through them really quickly. You get a 3D context. You can see things that you wouldn't normally be able to see. It allows you to fully explore historic features. You can capture detail. You can easily create floor plans for intensive level surveys. There's a safety aspect, and it also allows public access to these historic features. So 3D context. I think we're going to go ahead and start with a video. This is a video of the Olmsted power plant itself.
I'm just going to try to narrate what you're seeing as we go through this plant. We're driving along the side of the substation, and you can see the beautiful campus that's out in front of the hydro plant. Now we're going to go right through the front door, see the generator units inside the old plant. We're going to turn and go back behind the control panel, and behind there are the exciters and the breakers that actually shut the power on and off to the power grid. There you can see a great view of one of the turbines. Now we're going to go in the basement. We're going into the 1917 upgrade of this power plant. You see the compressors that were used to put air on top of the accumulators and the oil pumps that pumped the hydraulic oil that actually made the turbines operate. This is a view of the draft tube of the number 4 turbine, the one that was cavitated so bad, and then we're out through the walls and the penstock. I think it's kind of neat that you can kind of just fly through the walls as you look at some of this laser scanning. It really kind of applies to Halloween right now, I think. Anyways, just the ability to be able to see everything is just phenomenal with this.
This is definitely a great improvement over the old way we used to do it, by hand measuring facilities and taking still photographs. So the laser scan data it allows you to do a lot more. And we didn't show that as part of the video, but you can also take measurements anywhere in there. And I think there's another spot here that Nicole will show us how the measurements work.
All right, so this is a 3D point cloud viewer. It's a web-based program that we've developed. And I kind of wanted to, if you were to look at an aerial photo of this area, you could see the powerhouse and the carpenter shop and the brick stable. But this 3D point cloud allows you to manipulate it to also see, that the brick stable is higher in elevation than the powerhouse. You can see the retaining wall here. It gives you the ability to kind of to rotate and zoom in and out and around. Oh, yeah, right here. This is where the train tracks went in originally from that historic photo. So it's kind of neat how you can pan around and see that. It gives a much better perspective than just an aerial image or a photograph would give. The next advantage we want to talk about is how it allows you to see things you wouldn't normally be able to see. As Nancy calls it, it gives you Superman vision. You can see through the mountain, you can see the rock tunnel there and how it connects with the pressure box.
Yeah, and if I can just jump in here and break in, this was a huge benefit for us, because while we were under contract with PacifiCorp, we needed to get in and decide what we had to do to be able to line this rock tunnel, and we only had a window of a few days to be able to find out, what's inside here, the dimensions and everything else. With this 3D laser scan, we were able to go in and calculate how big a pipeline we could put down this tunnel, how much concrete it was going to take to backfill inside of the tunnel, and also that there was a couple of little places in here that the rock from the ceiling was actually going to interfere with the pipeline that we're going to put in this tunnel, and so that we can show right on the plans that we need to knock out this piece of rock or whatever we can do. We did that, all in a couple of days, and now our engineers can do anything that they need as far as the design on this.
It also allows you to fully explore historic features. This is the brick stable. And we'll go into the attic here, and just, or the loft, I guess is what it is. And Nancy, I don't know if it's the...
One of the things that I have really enjoyed about this is the ability to move from floor to floor. There's a truss right here that if I were just exploring this, I would have to run downstairs and try and figure out where this truss was coming through. There are tie rods that go from this truss, and I wondered why this truss was here. And we can go right through the floor, follow the tie rods down, and realize that there's a section here in the lower part of the stable where they kept carriages, and it needed to have no posts, like the opposite side had posts to hold up the ceiling, and that's where the horse stalls were. But anyway, to be able to move through floors was kind of a fun aspect of this, to be able to follow things like that. And the quarters building, which is the dormitory of the Telluride Institute, has a truss identical to this, which is much larger. Anyway, kind of help you understand different aspects of the building itself.
It also allows you to capture, great detail. I wanted to point out on this 3D point cloud that you can just cut out a section of the point cloud. Sometimes if you have the entire point cloud, it gets a little bit difficult to manipulate. It's a little bit cumbersome. So if you just want a small piece, it's pretty easy to just cut out that small piece. If you were to take a photo of these generators, you would be able to see the generators, but you wouldn't be able to see the turbines behind the generator, or how the water comes into the building and into the turbine.
Well, there's also bearings there. There's wicket gates that you can see. You can see the oil pumps and the governors and just a whole bunch of stuff that you would just have no opportunity at all to see unless you were inside the building.
And also, this web application allows you to measure. You can, from a photograph, you wouldn't necessarily be able to tell how large these are unless there was some context, if there was a person in there. But with this, you can actually measure, and you can see that they're about 12 feet in diameter. You can also cut cross sections. You can measure volumes. It's pretty fun to play with. I know my 10-year-old daughter, actually, I let her play with it a little bit the other day, and she was having a lot of fun with it. This technology also allows you to easily create floor plans for intensive level surveys. Nancy, she's going to explain how she usually creates floor plans.
Normally I need to go into the building with a measuring tape and write down the distance between windows. I have to know where the doorways are and how long walls are. And often I'll get back to the office and start going through my measurements and realize I've missed a measurement and I have to go back out, or my measurements aren't adding up and I kind of have to like squish a window and say, well, that one must be 3 feet 2 inches. And the other thing is, this is the blacksmith shop, and you can see from the photograph that the ceiling, the roof is no longer there, and that section of the blacksmith shop was not safe to go in, so I couldn't measure that portion. So the laser scan was extremely helpful, especially on this building.
So this is a 3D point cloud that's been brought into MicroStation, or you could also bring it into AutoCAD. And our CAD person, she cut a slice from the point cloud and then rotated it to a plan view, and then was able to easily trace and measure the building. I think it's pretty interesting to note that this this wall here isn't actually straight, it's bowed. And Kim, our CAD person, had to come down to Nancy and ask her, do you want me to draw it in bowed or should I draw it in straight? But it demonstrates the point cloud's ability to just give you so much more detail than you normally would get. And then here's the final product, which is actually pretty boring compared to everything we've been seeing lately, but we're going to be giving this information as well as all of the 3D point cloud information to the State Historic Preservation Office. There's also a safety aspect, and I'm going to let Daryl describe.
Hopefully I can do this. Can everybody hear me? No? Okay. Nope.
That mic should be working. You just need to talk into the. Okay. Okay.
Talk closer in this one?
Yeah.
Okay. All right.
Let's do number 4. That one, the wireless one. Testing.
Okay, this works. It's really interesting. This pressure box had the big gates that open and close the valves or the water into the turbines, and it also had some big screens up here. And in the historical days, they had to send an operator up here sometimes multiple times a day to go up and clean the moss and algae and sticks off of this screen. Well, in the wintertime, you can't access this, or in the summertime, you can't access this by vehicle because it's a wet, slippery clay dirt road and it's very steep in here. So there was a switchback trail that went up the side of the mountain, and the operators would walk up, and then they would walk over that bridge that's on the penstock and then up and into the building, and that's how they would access it. Well, when the Central Utah project came along, we started screening the water at the river at a 1/4 of an inch, and so that operation was no longer needed, and this bridge and the access trail deteriorated greatly. And so now to be able to measure the front of this building, you can't do it because the dilapidated condition of that walkway would be very dangerous to be able to walk across it.
I want to add a history. Really close. Can you hear me? I wanted to add a history part of that story that the operators who would go up and clean off the screens had a competition with each other, that they wanted to see how fast they could get down, and so there was a phone up there, and they would call the powerhouse and say, okay, I'm leaving right now, and they would run down the face of this slope, and the fastest time was 90 seconds. 375 feet down the mountain in 90 seconds.
We've also created, this is a preliminary website of the Olmsted campus that will allow the public to explore the different features. For example, if you click on these historic buttons, it'll bring up a side-by-side view of a historic photo as well as what the building looks like now. And there's also a historic documents tab that gives a brief history of the structure, as well as some historic documents. This is actually a letter from March of 1921 describing a fire that had destroyed the garage. And it's actually a really entertaining letter to read if you ever get the chance. If you click on this button here, it brings up a video of the fly-through that we showed a little bit earlier. And then any of these buttons here are panoramic views of the campus or of the different buildings. As the scanner is scanning, it's also taking photographs, as Stan explained. And so we're able to see those photos. And you can see how beautiful the campus is. And then if you click on these buttons here, you can see a floor plan of the different buildings. You can actually go into the basement as well. And these symbols are actually the 3D point clouds. So, and this is, like I said, it's pretty easy to manipulate. My 10-year-old daughter was able to do it. And you can also change settings to play with the appearance. If you want to give yourself X-ray vision, you can do a few things. And you can kind of see the interior of the building, the generators and the turbines and the control room. So it's kind of a fun thing to play with and to explore. Is there anything else with this?
Well, and I'll just mention that this is all part of the submittal that will go to the state history people. And Nicole mentioned that everybody should read the letter if you get a chance. And the good news is we can give you that chance. Along with this presentation, we don't really have source files. This is all done inside of a story map application. And so there's a web link. And so you can easily go, just click on the web link, and you'll be able to go in and see all of this information that we've showed you today.
All right, so how does this apply to transportation projects? We have a couple of examples in mind. The first one was the Center Street Viaduct in Provo. And it was removed as part of the I-15 core project. But it's a beautiful structure.
Is this working? Get really close. Is it working? I was asked to document this bridge before it was demolished, and after we started using this laser scan, I thought this bridge would have been the perfect thing to do this on. It was a beautiful bridge with a really rich, interesting history, and even driving over the top of it, you had no idea what was underneath, and when you're underneath, you can't really see the whole structure and the grace of the arch of it. It just was a beautiful bridge, and it would have been wonderful to have been able to document it and be able to explore it with the laser scan.
The second example we had in mind is just urban corridors in Utah. This is Syracuse Road in Syracuse, and there were several historic homes that lined the roadway. And these photos kind of give you a little bit of a feeling. It had more of a historic look and feel. It was a 2-lane roadway, and now it's for a rural area. Now it's a 5-lane roadway. And we think it'd be pretty easy just to go ahead and scan the whole corridor, and that would give you that whole context of what it used to look like before it was widened, before several of the historic structures were removed. All right, so I think we're done with our presentation if anyone has any questions.
Oh, sorry to cut you off, Nicole. I forgot in the introduction to let everybody know that we promised to get you out of here early. So hopefully that's a good thing, and hopefully nobody has hard feelings about that. But we wanted to open it up for questions, and I'm not sure, maybe we can walk around with the portable microphone if anybody has questions. Anybody? Right here in the front, Arthur.
How much time did you spend actual scanning on that campus?
The scans are very quickly. Most of the ones we did were the 12-minute scans, so we got the photos along with it. I believe it was off and on over a 2-week period to do all of the scanning for this campus, and we have lots of data, billions of survey points. So it's really quite quickly, or quite quick to do this scanning. If we were going to do a linear corridor or a roadway, we would probably set the scanner up every 300 feet. And when it scans, it does the full rotation and goes quickly. So at the most, it would be 12 minutes per scan plus setup time. Question in the back.
Just a historic place. So when exactly did they take the powerhouse offline? How long was that operating?
That's a wonderful question. I'm going to let Mr. Devi answer that.
The power plant has run for 111 years. It was shut down on September 21st of this year. Yes, and again, the reason for that is we have to start moving the buildings. We're installing some pipelines. We've ordered the new equipment for the new turbines that will be put in the new plant. And so the old plant will become a museum by appointment.
Well, and as we talked about, I think Nicole showed a lot of the different historic buildings, and Nancy talked about them. And unfortunately, a lot of those facilities are going to need to be removed to build the new power plant. It's really just the old power station that will remain. But we feel like with all of this survey documentation, all the laser scanning, we can really, you'll always be able to see what it looked like. You'll always be able to measure it. You'll always be able to do your own fly-throughs. So it's a very powerful application to preserve this information.
We probably ought to clarify that what's being removed is the buildings, some of the buildings on the back lot, that the campus front, which is still owned by Pacific Corp, where the Institute building and the residences are, will remain intact. And so the powerhouse faces that central campus area. So it's what's behind the powerhouse that will be removed.
More questions?
Yeah.
Right here.
How do you keep from overloading the computer with all this billions of points of data? You know, you have massive. What type of software or what kind of computer power do you need to keep from overloading?
That is a great question. I mentioned that it is a very data-intensive process. We have a lot of data. One of the stills, I guess, that Nicole's showing there right now was a cropped portion of the point cloud. So one way to better manage this data is to go in and separate portions that you need. If you were to look at that entire point cloud together, it's very slow. Basically, the faster the computer, the better. We try to use the most current technology we can, but it does still slow things down. And I think computers will continue to get faster, and so applications will get even better.
Well, and this is part of the reason we created this web-based viewer, so we could cut these portions out, and the density of the points isn't as great as you would if you were to look at a recap file, which is a lot greater. So this is a GIS-based, I think, mapping, and so it's pretty. I mean, I think we were running it off our iPads. The web-based 3D point cloud viewers.
Thank you, Nicole. Where's the microphone? Daryl has the microphone. Would anybody else have a question for us?
So your story map application that you guys had, did you develop that as well, or was that something that you got somewhere, or?
The questions about the story map, and those that were in the luncheon yesterday, Carlos just touched on this. He pulled up one still shot and talked about story map and indicated that, hey, this is going to be a part of our future in doing presentations this way. I'll let Nicole talk about the story map because she's the one that helped develop this for us.
It's a GIS-based product. The only reason we used it on this one is our GIS person overheard us talking about this presentation, and he was like, you guys should use a story map. So it is pretty easy to use. Once you kind of have everything set up, you can add text and photos and videos, but it's kind of all set up for you, and you just need to add the information, the GIS kind of based information. So.
Was there one more question in the back here in the middle? A couple of questions, actually.
My question would be, 100 years forward, how do you guarantee that this information will still be available for historic purposes 100 years from now?
The information, the point clouds are survey data. And granted, to be able to use all this in the future, you will need applications to be able to read the data and show the data. But I picture it being similar to like a PDF file. They've been around for quite a while, and even though new software applications are developed continuously, PDFs are still a good way to see things. But I think the responsibility is on us as we develop software and move forward to make sure that we're compatible with all of our older materials.
We had that same question come up with the State Historic Preservation Office, because this isn't something they normally deal with. And what we came up with for them was to give them this information in video format, because we felt like video was something that would continue, perhaps would stretch out longer. So we're doing fly-throughs to put in their office, because it's available to anybody who wants to go to the Historic Preservation Office, and it will be a DVD that they can look at. So that's the way that they chose to prolong the life of this.
Yes, sir.
As you're zooming in and out on the turbine, it almost looked like you see the blades. Am I really seeing that, or has that been added in, or?
Yes, let's have Daryl talk a little more about that. Nicole, looks like you've got the photo.
You can't actually see the blades on the runner, but what you can see is the poles on the generator and the big spokes that were on the wheel of the generator. So Nicole, if you can go to the old unit number 3 that doesn't have the guards on, I think shows it a little bit better. Yes, right there. Now zoom in on that a little bit closer. You can see that the whole rotor part of the generator was spoked, and so around this rotor was all of the electromagnets that created the field yes, you set up in several places, and so you can almost see through it, but you can move to the back side. It's just really interesting. You can see all of the detail of it.
As Daryl mentioned, you set up in multiple places. I know in some of our applications we can actually show you the different points where you set up, and you can click from one to the next. Question in the back?
Yeah, my question is, what's the difference in cost from this versus the old way we did it?
There is a cost savings. I think we mentioned that we did all of this scanning over this Olmsted campus off and on within a period of 2 weeks. And the amount of data you get is just immense compared to traditional methods. Where you run into a little bit more time is in processing the data, and depending on what you want to do with it and how you want to demonstrate the point clouds. But there is a cost savings in doing this, and I think that is why we're seeing it a lot more on UDOT projects. We're seeing laser scanning be incorporated in either by a subconsultant or by UDOT.
As far as the intensive level survey that's often required for a demolition of a building, the documentation on my part was significant. Like, it took me perhaps 10% of the time that it normally takes for me to measure and draw and be able to create a floor plan that goes in the document. It was significantly less time.
Well, and I think it eliminates the need to have to go back out into the field if you forget a measurement, and so there's that time savings as well.
Thank you.
As the customer of Horrocks, we hired them to do this. We felt that it was a bargain. What we got out of this, it was just a really great deal.
Other questions? We appreciate everybody taking time this morning to come and listen to this. We think it's exciting. We think it's innovative. We think it holds a lot as we move forward in the future. We're going to be up here if people want to chat, if you want to see things. And I mentioned there will be a web link circulated. As part of all of the presenters are turning in all of their source files, and there'll be a database put together by UDOT. So our source file will just be the web link. So please look forward to that. And appreciate everybody that helped out today, and appreciate the questions that we had. So thank you very much. Is this still on? Okay, we have, if you need a signed paper for continuing education, we have those up here. Otherwise, there's the sign-in sheet for in-state people if you just sign your name.